Okay, so find the volume of the truncated cone. You'll see what that means now in a minute. Okay, and it's also sometimes called a frustum. Correct to one place of decimals. Okay, so we're looking for the volume of this shape. Okay, so you have this frustum here. Your height is 8, your radius of this part is 6, and this part is 4. So a truncated cone, if you think about it, it's a cone, but you've got that top part removed, don't you? Now, you can think about that top part as being a cone that has been removed, because it's just a smaller cone removed from the full cone, isn't it? Are you okay with that? Can you see that?
Yeah.
Okay. So if we're thinking about this as being one big cone and a small cone, basically what we're going to have to do is we're going to have to get the volume of the big cone, and we'd have to take away the volume of the small cone on top. Okay, that one's on the top. So if we want the volume of these cones, we're going to need our volume formula, okay, which is pi r squared, sorry, it's 1/3 pi r squared h. Now, we're grand, we have our r's, but we don't have h's, okay. Now, a little bit of junior cert geometry is going to happen here. If we think about this as being a full cone, okay, you end up with two triangles, okay. You've got a triangle, I'll draw them down here, which is the big triangle, and then you have the smaller triangle on top, okay. So you have this one here, and you have this one here. Now the big one is 6, and we don't know the height, it's h. The small one that's a 4. Okay, and we don't know the height of the small one, but what is it in relation to h? If h is the whole thing, how would I get what this is?
8 plus 8.
H is the whole thing, you're on the right track.
All right.
So h,
Minus 8.
exactly, h take 8. Now, can you remember what these two things are called?
Adjacent.
These two triangles. What are we going to do with them? Something you learned in junior cert.
Congruent.
They are both right angle triangles, okay? We're not going to do congruency because they're not congruent. They're not exactly the same. What are they? They're alike. What's another word for alike?
Similar.
Similar. Yeah, we're going to do similar triangles. Okay, good. So similar triangles is when you put one side in this triangle over the same side in this, okay, and put it equal to this side over this side. So that's going to allow us to find out what h is, and once we find out what h is, we can use that to find the volume. Okay, so similar triangles, just write a note to yourself. You're doing similar triangles here. So if you're starting on the left triangle, so h over, what's the same side but in the smaller triangle? The corresponding side.
H minus 8.
Yeah, h minus 8, okay. So this side over this side, and you put it equal to, you started on the left triangle, so you have to start on the left again. I have another side here, that's 6. What's the corresponding side to the 6 in the small triangle?
4.
4. Perfect. From there, you're going to cross multiply. Okay, so the 4 comes up and the h minus 8 comes up and gets multiplied. So 4h is equal to 6h minus 48. And then all you're going to do is letters to one side, numbers to the other. Minus 2h is minus 48, so h is 24. So now I know the height of the big cone is 24. Everyone okay with what I've done there?
Yeah.
Now another way to do similar triangles, you can put h over 6 equals h minus 8 over 4. You can do it that way if you want to work all on the left equal to all on the right. That's totally fine too if that's the way you learnt it. Okay, so now we have that h is 24, we can start working with the volume. Okay, so we need the volume of the big cone and we're taking away the volume of the small cone. Can I get rid of this similar triangles part?
Yeah.
Okay. So we know our volume is 1/3 pi r squared h. So the volume of the big cone is 1/3 by pi by r, which is 6, by the height of the big cone, which we found was 24. Okay, so that's 288 pi.
That's the big cone you're doing now.
The big cone, yeah.
Oh, yeah.
And then I'm going to get the volume of the small cone, 1/3 pi. Now the small cone is this on top here. Okay, so my r is 4. What's my h? This whole thing is 24.
Minus 8.
Yeah, 24 take 8, exactly. Okay, so you end up with 16. So that is 256 over 3 pi. Okay, and if I want to get this frustrum or the truncated cone, this little bit that's left, I'm just going to take those two answers away. 288 pi, take 256 over 3 pi. And they want to correct one decimal place, throw it into your calculator and press S to D. And we're talking about volume, so it's centimetres cubed. Is that okay? Okay. Now, just a little bit more to do with tolerance and error. Okay, so I just have a few formulae for you to write down. Can I get rid of the board?
Yeah.
Okay. Okay, so just a subheading. So percentage error, tolerance, degrees of accuracy. Okay. Now, you did percentage error in junior cert. Can you remember what the formula is? For example, if I tell you I've estimated the volume of something to be 100 mils, okay, the true volume is 125 mils. Okay, and I'm looking for the percentage error on this. So your formula is error over actual multiplied by 100 over 1 or 100. Okay, so you get the error, you put it over what it actually is, the true, and then you multiply by 100. So in this case, what would the percentage error be? What's your error? Go on.
25.
Thank you. Over what's the actual volume? 125. So the actual is the true. It's what you not what you estimated it to be. It's what it actually is. Okay, and then you multiply that by 100. Okay, so in that case it's 20%. So that's a formula you need to learn. Okay, error over actual Then tolerance, okay? So you know, you always ask me when we're drawing graphs and the marking scheme, you know, what did they allow? Did they allow you a unit or whatever? That's called tolerance, okay? So tolerance is measured and we use half a basic unit, okay? So it's your measurement plus or minus half a basic unit, okay? So for example, if we're talking about weight in kgs, your tolerance would be plus or minus half a kg. If we're talking about length on a ruler, your tolerance would be plus or minus half a millimeter, okay? So it's half the basic unit. Okay, now you're talking about the smallest size on that scale, so that's why we went with millimeters for a ruler. If we're talking about a clock, the tolerance would be seconds. Okay. Now,
for the first example,
yeah,
where did you get the 25 from?
the 25 is the error. So if I estimated it to be 100 and it actually is 125, I made a mistake of 25. So that's where it came from.
Oh, okay.
Is that okay?
And do you multiply whatever the estimated value is, not just get a percentage in it? Or
Say that again?
the 100 is just to get a percentage,
Yes.
not the estimated value?
Yeah, no, that's just to get a percentage, exactly.
Sorry, sorry, Miss, came on there, my computer crashed.
Perfect, no bother, Jane, that's grand. Okay, and the last one is degrees of accuracy, okay? So in general, we're using correct to 2 decimal places or 3 decimal places, okay? So just something to be aware of, okay? For example, if a length is 10.3 centimeters correct to 1 decimal place, you just need to think about what could it have been before you took it to 1 decimal place, okay? So what was the smallest possible length 10.3 could have been? Now it was rounded to 10.3, okay? So it could have been 10.25, couldn't it? Because 5 or higher, you round up. If it was 10.249999, you'd have left it at 10.2. Okay, so that's the smallest it could have been. And what about the biggest it could have been?
10.34.
10.34999 exactly. Okay, basically just under. Sorry, can I just get rid of that? Just under 10.35. Because if it was 10.35, we'd have rounded it up to 10.4. So that's just something to keep in mind. Okay. Now, I just want to do one example using this type of thing. Can I get rid of the board? Okay.
Are they kind of like rules that you have to know?
Yeah, exactly. Just things that you need to keep in mind. If they say, like percentage error, it'll be very clear they'll ask for the percentage error. But degrees of accuracy, it's just something you need to remember. What could it have been now that it's been corrected? Okay, so it's just basic understanding, really, as opposed to it, coming up specifically in a question. I'll do a tolerance question where you'll see the way they ask it. Can I get rid of the board?
Yeah.
Okay. Matt.
Or not?
Matt.
Oh.
I'll put 2 T's there. I don't think they have it in the book, but sure. Okay, so Matt weighed 85 kg before training and 81 kg after. He took both measurements on a scales measuring in kg.
You actually lose that much in training session.
Pardon?
You can't actually lose that much in one training.
No, I think they mean before training, as in he might have done a program for 6 weeks or something.
Oh, right. Game.
Unless he's a professional boxer or something. Now, find the minimum and maximum values for his weight loss. Okay, so they've told us the scales is in kg. So what's our tolerance?
Half kg.
Yeah, plus or minus half a kg. Okay. So that means before, what could he have weighed before?
85.5.
Yeah, 84.5 or 85.5, exactly. Okay, that's his before values. He either, this overestimated him by half or underestimated him by half. And his after is either 80.5 or 81.5. Now, they're at, yeah? You okay?
Is the tolerance always the same?
Tolerance is always plus or minus half a kg or half a basic unit, yeah. Okay, so it just depends if we're talking about weight or length. It depends on the units we're dealing with. Okay. Now we're looking for the minimum weight loss, so the smallest amount, and then we're looking for the biggest amount. Now let's do the biggest amount he could have lost. Okay, max weight loss. Now, if we're talking about the biggest amount he could have lost, we want him to be heaviest at the beginning and lightest at the end, don't we? Does that make sense? So we'd assume he was 85.5 at the beginning, and after he was his lightest, 80.5. Okay, so that would say his max weight loss was 5 kg. The minimum amount of weight loss, we'd want him to be the lightest before, and we'd want him to be the heaviest after, because he's going to lose the least amount then. So it would be 84.5 before and 81.5 after. So that's 3 kg. So there you have your min and your max values for his weight loss. Is that okay?